Let's see how we can use some calculus in this example. This problem says that an object moves in a straight line according to the equation x of t, right here, is equal to 2t cubed minus 3t squared minus 6t, and x is measured in meters and t is measured in seconds. And we're asked to find what is the object's velocity at exactly 3 seconds, and then when is the object's acceleration equal to 0. So first of all, let's start out and say, well, velocity is the derivative of position, and this is the object's position function because it says object moves in a straight line according to this equation. So the first thing we need to do is say that the velocity as a function of time is equal to the derivative, or x prime of t, so the derivative of position with respect to time of this original function up here. So let's now take the derivative, reminding ourselves that the derivative of a sum is the sum of the derivatives. So in the first case, for 2t cubed, we'll take the 3 round the front, multiply it by the 2, and get 6t squared, because we have to reduce that exponent by 1. Then minus, and then 2 times the 3, so again 6t, but squared, reducing that by 1 just leaves us t to the first, and then minus 6. So this is the velocity function of this object whose position function is right here. So it asks us, what is the object's velocity at exactly 3 seconds? Well, what that means is we need to take the velocity function that we just generated here and plug in 3. So let's look for a v of 3, and that's equal to, of course, 6 times 3 squared minus 6 times 3 minus 6. And when we go and evaluate that, we get 54 minus 18 minus 6. Well, that equals 30. So meters per second. So the answer is, to this first part of the question, the object's velocity at 3 seconds is that its velocity at 3 seconds, v of 3, is 30 meters per second. For the second part of this question, when is the object's acceleration equal to 0, we need to remind ourselves that the derivative of velocity with respect to time gives us the acceleration. So we need to differentiate the velocity function, and we need to say the derivative of velocity with respect to time is equal to acceleration with respect to time, and that is equal to 2 times 6 is 12, 12t to the first, which we won't write, minus 6. And then, of course, the derivative of a constant is 0, so it would be like minus 0, but that doesn't really matter. And so when does this equal 0? So let's set that equal to 0. 12t minus 6 equals 0. Well, at this point, it looks pretty easy to solve this for t. So 12t, I'll add 6 to both sides, equals 6, and divide out the 6, and divide out the 12, and t is equal to 0.5. So then, therefore, at 0.5 seconds, this object's velocity is equal, this object's acceleration is equal to 0. All right.